On radian measure, so we filled out radian stuff with degrees 2 days ago on your unit circle, so having it out might shorten things a little bit for you. But we're going to be using radian measure, and we're going to talk about where that comes from. So to find the length of an arc of a circle, that is going to be the completely new stuff. So a central angle of a circle is an angle with a vertex at the center of a circle. So within that circle that I had for you on there, go ahead and draw a central angle. So the vertex is right smack in the middle, and then just draw an angle. Doesn't have to be any angle in particular. Okay, but this is an example of a central angle. An intercepted arc is the portion of the circle with endpoints on the sides of the central angle. So it's the arc in between the two rays. So intercepted arc, it's that arc between the two sides of the angle. You may have covered that in geometry, you may not have. If you did, you may not remember, so we're gonna cover that again. But that's, I already summed that up. Okay, a radian is the measure of a central angle that intercepts and arc with length equal to the radius of the circle. The radians, like degrees, measure the amount of rotation from the initial side to the terminal side of an angle. And then we labeled the unit circle the other day. Okay, so again, having that out will be helpful. We can convert angles from degrees to radians and from radians to degrees. So this is where all those come from. So this is why pi fourths is 45 degrees. Okay? Or pi halves is 90 degrees. So if you change radians to degrees, you multiply it by 180 and then divide out the pi. So the pi reduces out. You multiply the numerator by 180. To change it from degree into radians, you multiply it by pi by inserting the pi and then divide it by 180. So that's where all of those fractions that we put in around the unit circle come from. All right. So we're going to start off with those. So you'll need to know this from memory. So start memorizing it. We're going to use it multiple times today. So if we're going from degrees into radians, on example 1, you're going to multiply it by pi over 180. Okay. Now you can kind of ignore the pi temporarily. Does 60 reduce with 180? I should not see thumbs. How does 60 reduce with 180? More. By? Higher than that. 60. 60 goes into 180. Okay. Which leaves you a 3, yes. So 60 would go away, the 180 becomes a 3. Okay. So they reduce by 60. Now 60 is on your unit circle, is pi thirds the equivalent radians that we wrote the other day. Okay, it should be. So that's why those are paired up the way they are. All right, now 30 degrees is supposed to be what? In radians, pi 6. So the reason for that, if you multiply it by pi over 180, 30 goes directly into 180. So they can reduce by 30. 180 divided by 30 is 6. So that's where pi 6 comes from. So the other day I just kind of told you what they were, but this is where they come from. Now, 510 is not on the unit circle. Okay, so this is where you need to know how to calculate that. So, we're going to multiply 510 by pi over 180. Now, I want to at least see what you're multiplying by, but if you want to reduce your fractions within your calculators, you can do that. So, I'll show you very quickly how to do that. So, if you do 510 divided by 180 and hit math fraction, it'll reduce it for you. So this would be 17 pi 6. So you just insert the pi after the 17. You can reduce it by hand. On these cases, that's a little bit faster than using the calculator. But on the ones that are a little bit larger, those would both reduce by 30. So you can do it by hand to get 17.6, but you do have permission to use the calculator as long as you show me what you're multiplying by. Fair? So questions on how to do degrees to radians. So now we're going to do the opposite. So you just multiply it by the inverse of that fraction. So the 180 goes on top, pi goes on the bottom. Now pi is just going to reduce out, so you don't really have to worry about it too much. So we're multiplying this by 180 over pi. Okay. So the pi's will reduce. Now does the denominator of 3 go into 180? How many times? 60. So the 3 will go away, and you're left with 60. So we have negative 5 times 60, which is what? Negative 300, okay, degrees. All right. Is 5 pi thirds on the unit circle? Okay, it's positive, but that's at positive 300. So if it's negative, it's at negative 300. Okay. What about 7 pi fourths? It should be negative 315, right?
Yeah.
So if we multiply by 180 over pi, so using the calculator on these, let's say you don't have your unit circle handy, and you don't know how much 4 goes into 180, which it does by 45, but you can just go straight into your calculator and do negative 7 times 180 divided by 4, negative 315. But yes, if you see it on the unit circle, you can go ahead and write it, but just make sure it's negative if it starts negative. Is 11 pi fourths on the unit circle? No, so that just means it's going to be larger than that. So again, you're going to multiply this by 180 over pi. You can ignore the pi's because those will reduce each other out anyway. So 11 times 180 divided by 4 is 495 degrees. So at the very least, I want to see this on these problems in your homework. Even if you use the calculator, I want to see what you're multiplying by to get there. Okay. Sometimes it's faster to reduce in your head, but sometimes the calculator is going to help. Okay. Questions before we move on? Okay. This is somewhat review from yesterday. Okay. Now to draw the angle, where is pi fourths? What degree equivalent is that? How many degrees is pi fourths?
45 degrees.
It's 45 degrees. So we're talking about 45 degree angle just in radians. If you wanted to convert it to degrees, if that's easier for you to think about, that's fine. Just know that they're the same angle. Okay. Now, what is the coordinate at pi fourths or 45 degrees that we did yesterday? It would have been on the back. What's the xy coordinate? Rad 2 over 2 and rad 2 over 2. So if you're finding the cosine and sine, you can use the triangles, but cosine and sine have a very quick relationship. Whoops, sine. That you can memorize as an alternative. How do we find the cosine of a point on the unit circle as fast as possible? It's the x-coordinate. Okay. Now they're both the same, so 45 degrees is one of the easiest ones. So the x-coordinate is rad 2 over 2. Now if you did the triangle, which some of you are doing, which is fine, it's the adjacent side, which is rad 2 over 2, over 1, which is still rad 2 over 2. So either way, you're going to get here. All right, so cosine is always the x-coordinate on the unit circle. Okay. What's sine? It's the y-coordinate, yes, which is rad 2 over 2. So 45 is the easiest one. Okay. So sine is the y-coordinate, cosine is the x-coordinate. How do you find tangent, since that's not on here today? Either opposite or adjacent, which is the y-coordinate divided by the x-coordinate. Okay. So the tangent, in case you need to know, in terms of the coordinates, is y divided by x, which would be rad 2 over 2 divided by rad 2 over 2, which would be 1 in this case. Okay. So if you're doing it in terms of coordinates, x-coordinate, y-coordinate divided by the x-coordinate. Okay. If you're doing triangles, this would be opposite over adjacent. Sine is the opposite, cosine is the adjacent. So that's how they're all kind of tied together. Today on your homework, it's just going to ask you for either a sine or a cosine. So if you use the coordinates, that's fine. Okay, so that's where you can get away with not showing any work on those. Okay. Questions on that? That's kind of review from yesterday, just with radians. The one in the back is new. It's not tough, but it's new. So length of an intercepted arc. For a circle, the radius of r And the central angle measured in theta, in radians, so you're gonna see radians for these. The length of S, which is that arc, is S equals R times theta. So this little formula right here, that's what we're gonna use down here. Now the result of these is gonna be decimals, so we're gonna actually use the value of pi in the calculator for these. All right. I think she might have already left. She's not here.
Okay.
All right. So using this circle, we're trying to find S. So there's 10. So S equals R times theta. If you need to know how to write a theta very quickly, so it's like a 0 with a little curved line through it. So continue the little tail on it. Or just put a 0 with a line through it. I'll get the message. Okay. What's the radius of that circle? 3 inches. Okay. Which angle are you looking at to find S? 5 pi 6. If we were finding B, you would use 2 pi thirds. So make sure you pay attention to which one you're finding. So it's S in this case. So 5 pi 6. If we are reducing that, how could we reduce it very quickly? So 3 and 6 can be reduced by 3. So 3 would go away. 6 divided by 3 would be a 2. So this is equivalent to 5 pi over 2. But it does want it to the nearest tenth. So this is where you would go into your calculator. Do you guys know where pi is?
Yeah.
Where? For those of us that don't know. Second, and then the button right under clear where we usually do an exponent, so the little caret. Okay. So 5 second pi divided by 2. So the nearest tenth would be what? 7.9, and then whatever the radius is, so since it's inches, 7.9 inches. In your homework, it might be meters or centimeters, so make sure to pay attention to that. So again, if you need to know where pi is, on the calculator, it's second, and then that little caret button right under clear. I'm guessing most of you have used that before, so just to review. Pretty easy? All right. So on your worksheets,